moving on to the next section of mechanics, and we're going to look at moments and torques. So what is a moment? Well, a moment is the turning effect of a force, and we calculate it in Newton meters by multiplying the force by the distance that the object is from the pivot point. Let's look at this example of Garfield, who is sitting on a seesaw. And obviously Garfield is going to move downwards on the seesaw because there is a moment created. And the moment is created by Garfield's weight F, and he is sitting a distance d from the pivot point, so the moment is going to be equal to F multiplied by d. If there is no turning, the moments must be balanced, and here we have persons A and persons B, or Mr. Large and Mr. Little, who are sitting on a seesaw. If Mr. Little is 500 newtons in weight and he is sitting 2 meters from the pivot point on the seesaw, and Mr. Large weighs twice as much, then he has to sit 1 meter from the pivot point in order for those moments to be balanced, in order for moment 1 to be equal to moment 2. Here we have a diagram which demonstrates the principle of levers, and in a lever an effort force acts against a load force by means of a rigid object which rotates around a pivot point. So here we have examples of a wheelbarrow and also of a foot, and in the foot example we can see that the load force is the weight of the person acting downwards, the fulcrum is around the toe joints, and the effort force is the effort produced in pushing up onto the toes of the foot. Now moments are quite important. Let's look at Bob, who is trying to carry a box with an outstretched arm. Let's say Bob's arms are 1 meter long and the box weighs 5 newtons. The moment of the force will be equal to the force multiplied by the distance, which is 5 newtons multiplied by 1 metre, or 5 newton meters. Now remember, the pivot will be his shoulder joint. That's the load force. Now the back is asked to provide an effort force because Bob wants to hold the box steady. He doesn't want any turning to be involved. And the back is a distance 0.1 metres from the pivot point, from the shoulder joint. And you are asked to work out what the reaction force must be from the back for Bob to be able to hold the box steady. Well, if the box is steady, that means there's no turning, so the moments must be balanced. The moment at Bob's back is the force times the distance from the shoulder joint, which is the force times 0.1 metres, and we know that the moment must be equal to 5 newton meters. So for the moments to be balanced, Bob's back must use a reaction force of 50 newtons. And this is why, when handling objects, it's always a good idea to draw them close to the body and carry them close to the body, because you are going to create a bigger moment when you carry them far away from the body, and you are going to need to use your back muscles more and create more forces through the back, which could damage it. We're moving on now to look at couples, and a couple is a pair of forces which are of equal size and which act parallel to each other but in opposite directions. From the diagram you can see that there is no resultant linear force, the forces are balanced, but they do produce a turning force, and this turning force is called a torque. And the way that we calculate a torque is we take the size of one of the forces and we multiply it by the perpendicular distance that is between the forces. And that concludes this part of the mechanics course.
Created using Powtoon.